Okay, so let's look at neural control of the heart. So we know that autorhythmic cells can depolarize on their own, but they're also manipulated by the cardiovascular center in the brain. So where's the cardiovascular center? When you should know this, it is in the medulla. So if we have our little medulla here, so parasympathetically, well, let's look at where we're getting information from the heart first. Okay, so how do we get information from there? So we get information from sensory receptors. So basically we have proprioceptors. Those are in the muscle. Okay. Then we have, and they look at tension in the muscle. Then we have chemoreceptors. And they look at what's going on in the blood, right? So things like acidity. So basically hydrogen ion concentration. All right. And then we have baroreceptors. Baroreceptors, I guess is what they are. So baroreceptors are in the vessels. And they're located, again, in the vessel. And if we look at that, well, they measure pressure. So they basically measure stretch of that vessel. So if we have, here's our baroreceptor there, and there may be a baroreceptor, off of one of these vessels too, whatever. So baroreceptors are there, and they communicate back to the medulla. And they communicate about stretch. So if stretch is high, then pressure is going to be high. If stretch is low, then that means pressure is going to be low. Basically, the more blood that's in the vessel is going to cause the vessel to stretch more. The less blood that's in there is going to cause it to stretch less. So parasympathetically, there are nuclei here, and they will target, well, they have, let's see, better color there. So they have neurons that will target the nodes. So the SA node and the AV node. And if the pressure is too high, then it will slow down the SA node and or the AV node, which I kind of did that not right, because, let's see, let me show this better. Because remember, we're talking about parasympathetic, we're talking about the ANS, which is a 2-neuron thing. So here's neuron there, neuron here, and neuron there. Okay. So that will slow down, well, decrease pressure. Decrease pressure by slowing heart rate. Okay. Sympathetically, so remember the sympathetics are in the lumbosacral, or excuse me, lumbosacral, thoracolumbar part of the spinal cord. And there are neurons there. I'll do them in yellow, I guess. No, that's not working. And that you can't see very good. Let's do that in this little crazy blue. Sorry. Okay. So there are neurons here that go out to the sympathetic chain and then send information back to the heart. So when pressure is too low, then it will increase it. By increasing heart rate and stroke volume, basically increasing cardiac output. Okay, so it increases heart rate, increases stroke volume. So depending on the information coming back from these receptors back to the cardiovascular center, then it will answer depending on whether the need to increase pressure or to decrease pressure, depending on what it's sensing from these receptors. So that's basically how we have control of, or neural control of the heart, is through the input of these things to the heart, through these sensory receptors.